Okay, hope you're doing well. We're going to cover just a quick video with equilibrium constants and how they relate to potential. And again, if you recall, there was a delta G equation that was related to the equilibrium constant like this. Well, again, if you just divide that by negative RF, you get RT over NF ln K. So that would be the way to figure out the standard potential from the equilibrium constant, or vice versa, right? And that's what we're going to do here. So we're going to first figure out the Ks, or find the potential in order to figure out the KSP for this thing. So the KSP reaction that we want is, if we recall, the kind of dissolution of some salt, some ionic compound, into its ions. That would be our KSP reaction. This is a reaction for KSP, right? And so we want to use these two half reactions that are given to kind of add up and give this overall reaction. So what we're going to do is look at these and flip the first one around, because the first one has lead sulfate as a product. So we're going to reverse the first reaction, or half reaction. Will be PbSO4 plus 2H2O goes to PbO2 plus 4H plus SO4 2 minus plus 2 electrons. That's going to be negative 1.69. And the other one we're going to keep the same. PbO2 plus 4H plus 2 electrons goes to Pb2 plus and 2 water. That's going to be 1.46. Okay. Well, lo and behold, we're going to cancel out a lot of things like PbO2, the 4H plus, the 2 water, the electrons, and then we're going to have, just like we said, the reaction that we want for the KSP value, which is just basically dissolving and dissociating lead sulfate. So the E naught value, if we add these together, is negative 0.23 volts, right? Which is not a spontaneous reaction, which makes sense because this is actually what we call an insoluble salt, which is the case when we're doing KSP. These are always, weak electrolytes. So these are, like, a better accurate arrow would be an equilibrium arrow, because this is not a completion reaction but an equilibrium situation. And so then we can go backwards to find K. So if we take our E naught equation, RT over NF ln K, and solve for K, we would get K equals E to the NF over RT. NFE. I was missing two E's there. E to the NF E naught over RT. Okay, so again, just taking this one here, solving for K. NF E naught over RT. And we can then plug in everything. We know that the N value is going to be 2 Faradays. We have our potential in volts. It's a negative number. And then R, 8.314, and then 298. Okay, so what did I get here? I got E to the negative 17.9, which was 1.6 times 10 to the negative 8. That sounds pretty reasonable for a KSP value. They're usually, again, pretty small numbers, if you recall. And these reactions are, weak electrolytes, or these solutes are weak electrolytes, and so the reaction heavily favors the reactant side. Okay, hope that makes sense, and I'll talk to you in the next video.